Okay, students, let's go ahead and get started. As usual, the first thing we need to do is an audio check. So for Vicki, Ryan, and David on the session, if you can hear my voice, click on the check box, okay? So Vicki can hear, Ryan can hear. Okay, so David, can you hear me okay? All right, great. I'm going to lower everybody's hands. So the purpose of this session today is to do a pretty thorough review for the assessment quiz that's going to be taking on Monday and Tuesday of next week. So I need to first display a PDF document. So give me a couple of seconds to take care of that. Now what you should be seeing now is a PDF document that has the formula sheet that you're going to be using. My home telephone is ringing, so I'm sorry for the interruption there. Now the formula sheet that you see here is exactly the same as what you will see when you take the quiz. The only difference is that the annotations that are here will not be there. So it's very, very useful for you to go over and study this formula sheet to acquaint yourself with the purpose of each formula. So I'm going to quickly go over some of the variable values. So looking at the little information on the left-hand side. So let's start with Q. Q is a variable for the quantity to order, if this is an economic order quantity, or the quantity to make, if it's an EPQ. The Q with a little O underneath is a subscript, stands for optimum, so that would be the optimum order quantity or the optimum production quantity. Capital D. Now students, this variable is important. The definition of capital D is annual demand. So sometimes annual demand will be given to you, and sometimes you will need to calculate it. So if it's not stated exactly, then you'll have to calculate it by either multiplying by the number of months or the number of days to do that. P is price, but price, that variable is only used in the total cost formula for EOQ with price discounts, and I've already announced that you're not going to have a problem on that, so we'll just skip over that. H is the holding cost or the carrying cost. It's used in both formulas. S is also used in both formulas, but the definition of S is different. When S is used in the economic order quantity, it represents what we refer to as the ordering cost. When it is used in the economic production quantity, S is used to represent what we call the setup cost. TC is pretty obvious. That stands for the total cost. Little p is the production rate, usually stated in days, so you can produce so many a day, and that is only used in economic production quantity problem. Little u is usage. Now, a synonym for usage is demand, okay? So what would be the usage or the demand rate, usually in the same time unit of measure as P? So if P says you can produce X number per day, then the U would be what would be the usage or the demand per day. Little d is quite a bit different from capital D. Little d represents the demand during the lead time, and this is a component of the formula for calculating the reorder point. Lead time is pretty straightforward. That's the time in economic order quantity. So when you place an order with a supplier, what's the usual time it takes for that order to be received? And Double S stands for safety stock. So safety stock is an extra amount of inventory to take place. Now looking at the formulas in the middle of the page, you notice that the first formula is the total cost formula for basic EOQ problems. And I've already stated that you're going to have a basic EOQ problem. So that will be your formula for doing that. The next formula down is the formula for calculating the economic order quantity. The third one from the top is the total cost formula for EOQ with price discount. You're not going to need that one, so don't go there. The fourth one is the total cost formula for the economic production quantity problem, and you will have one of those. The most common mistakes that students make in this quiz is using the wrong total cost formula. So just remember, it's the one on top and it is the fourth one down. Those are the two that you need. Notice some of the formulas are for economic production quantity and some of them are for economic order quantity. So please study this formula sheet very well before you go take the test. Now I want to go through a couple of sample problems. So the first sample problem is shown here. An item purchased from a supplier costs $20. The average demand is 5 per day. It costs $5 every day an order is placed, and the inventory carrying cost is 20% of the purchase price. And the store works 200 days per year. The supplier lead time is 4 days. So the first question is this an economic order quantity problem or is this an economic production quantity problem? Okay. Well, it's an economic order quantity problem, and we know that for two reasons. In the first sentence, we see the word purchase. So if we see in the verb or an adjective to be purchase, buy, or something like that, it's going to be economic order quantity. There's a second way that we can identify an economic order quantity, and that is if an ordering cost is defined. So the third sentence says it costs $5 every time an order is placed. Well, that's the ordering cost. So we know that this is an economic order quantity. So the first thing that you should do is write down the values for the variables that are needed in the formula. So we need to know what the annual demand is. The annual demand is not stated. So we're going to need to calculate what the annual demand is. So if we have a daily demand of 5 per day, and we work 200 days in the year, then the annual demand will be the product of those two numbers, or 1,000. S represents the ordering cost. Nothing. Ordering cost is going to be stated. Usually there's no tricks or anything like that. It's just a flat $5. Now holding cost can be described two different ways. If you go back and you review the lecture material, I talk about both methods. One method is a percent of price, which that method is used in this problem here. So the holding cost is 20% of the price of the item. The price of the item is $20, therefore the holding cost is $4. The other method for describing holding cost is just a flat dollars and cents. Just a flat dollars and cents. So either if you get a percent of a price or you get a flat dollars and cents, you're going to end up with the same thing. Now, the next thing we need to do is to write the formula. So one of the grading criteria for the quiz is you must write the correct formula in order to get full credit. So this is what I mean by writing the correct formula. So you could write either EOQ or Q optimum equal to the square root of 2ds over h. So now we'll insert our variable values into this formula. and do the calculation, and this calculates that it is 50 units. That is, every time that we order, we should order exactly 50. Now, one mistake that some students will make, it's not a common mistake, but it's very easy to make, is that they will insert the wrong variable value into the formula. So instead of inserting $5 for the ordering cost, some students will get mixed up and insert the $4 for the holding cost, and vice versa with the holding cost. Instead of putting in $4, they'll get mixed up and put in $5. So if you make that mistake, you're going to get the wrong answers. Also, since your answer for the economic order quantity is going to be used in answering all the other questions, it's very important that you know that you have not made a mistake in this calculation. If you make a mistake here, it is going to compound your errors with the other parts. So take a few extra seconds and go through the calculations and just make sure that you have this exactly correct. Second question is, what is the average inventory? Well, average inventory is not actually a formal formula for that, okay? So basically, the average inventory is the economic order quantity divided by 2, or in this case, it's 25 units. The third question is, how many orders do we place per year? So the formula for that is the annual demand divided by the economic order quantity. So we are going to be ordering 20 times per year. Question number 4 talks about the time between orders. Okay, so how many days should be between 2 consecutive orders? So the formula for it is the inverse of question number 3. Just flip those two, numerator and denominator. So it's going to be our EOQ divided by the annual demand. So that's essentially a ratio, those two things. But then we have to multiply it by the number of days that we work per week, or if the problem states that we have a certain number of work weeks, we would just multiply by the number of work weeks. And what you don't want to do is you don't want to try to, if the problem states a number of work weeks, you don't want to try to convert that to days, because the problem is not going to state whether you work 5 days a week or 6 days a week or 7 days a week. So don't even attempt to do that if the problem states that there are so many weeks per year. Your answer would be that it would be 3.2 or whatever it turned out to be. Now in this example here, in this problem, we stated that we worked 200 work days, and so the answer to question number 4 is 10 days would elapse between orders. And then finally we have the total cost formula. So we know that the total cost formula, so the Q over 2 is the average inventory. We do that from step number 2. So what was the average inventory times the holding cost? And then D over Q, if you look at it, D over Q is the equation that we used in step number 3, orders per year. So D over Q is how many times we're going to order per year, and then what does it cost us each and every time that we order. So both of those calculate to be 100, so the total cost for the year will be 200. Now just remember that at the economic order quantity, these two the annual holding cost and the annual ordering cost should be the same. Now let's go to question number 6. Question number 6 wants us to ask, what is the reorder point if the inventory wishes to carry a safety stock? The company wishes to carry a safety stock of 5. So let's remind ourselves what reorder point is. Reorder point is that inventory level or below where we should place an order. So as the inventory starts to go down, it reaches kind of a magical inventory level, the reorder point, and when it hits that, then it is time to place a new order. So the formula for the reorder point calculation, there are two formulas. There's one with safety stock and there's one without safety stock. So since the problem stated safety stock, we'd use the one with it, is little d times the lead time, and then we're going to add to that the safety stock. Now in this problem, little d is stated. So I'm going to scroll up a little bit. We can see that in the problem statement it says that the average demand is 5 per day. But sometimes the demand per day is not stated. You may need to calculate what little d is. So there's a little unofficial formula for calculating little d. This means it will not be on your formula sheet. So a little unofficial formula would be that little d is the annual demand divided by the number of workdays. And we can see that we get exactly 5, which was what was stated in the problem. So the reorder point, if we have 5 per day, and it takes 4 days to get a shipment in, then we're going to consume another 20 out of inventory over those 4 days while we're waiting for the shipment to come in. But we want an extra 5 just to protect us in case something unexpected happens. So we'll add 5 to that, so therefore the reorder point is 25. When the inventory level gets to 25 or below 25, it is time to place a new order. Now students, I'm going to go through an economic production quantity problem here. So the Dine Company is both a producer and user of brass couplings. The firm operates 220 days per year. The annual demand for the couplings is 11,000. Couplings can be produced at a rate of 200 per day. The storage costs are $2 per coupling, and the cost to set up a production run is $70. So how do we know that this is an economic production quantity problem, other than to look at the tile here? Well, one is we can see that we are producing. So the first sentence says we are a producer. The second is to see that there is a setup cost defined. Now, the setup cost may sometimes be worded in such a way, something like this. It might say the cost to prepare the equipment to produce is X. Well, that's essentially saying that you have a setup cost. So setup cost is the cost it takes to just get the equipment ready to manufacture whatever it is that it manufactures. If you think of an oven, before you bake something in an oven, you bake cakes or you bake cookies, you have to preheat the oven to the desired temperature. So the time it takes and the cost of preheating that oven to the desired temperature is essentially the setup cost. So we're going to write our variable values. Now in this case, the annual demand is given for us, so there's no calculation needed there. The annual demand is 11,000, okay? The holding cost, so the storage costs are essentially the same. What we're talking about there is the holding cost, the carrying cost. That's going to be $2. Now notice, students, that the wording on the storage cost says $2 per coupling per year. Now there's some students who, when they see the word per in there, they feel like that they need to multiply the holding cost by something. Please don't do that. That is absolutely incorrect. The definition of holding cost is this. For this coupling, if we kept one coupling in inventory for 1 year, 365 days, is going to cost us an additional $2 over and above the cost of making it in the first place. So you don't ever multiply these holding costs by anything. So it's just $2, that's it. The setup cost is pretty straightforward. There's not going to be anything tricky about that, $70. The production rate, it clearly states that the couplings can be produced at a rate of 200 per day. So that's very clear. So usually the production rate will be stated in a rate per day. Now we need the usage rate, U. Now in this example problem, the usage rate is not given to us. We're going to have to calculate it. Well, it just so happens that the usage and the little d in the reorder point are essentially the same thing, and we can use the same unofficial formula for little u that we used for little d. So once again, this unofficial formula, little u is equal to the annual demand divided by the workdays, can be used, but it's not going to appear on your formula sheet. So if we divide 11,000 by 220, then we have a usage rate or a demand rate of 50 per day. So the first question is to calculate what the optimum economic production quantity problem is. So I've written the formula for it. So remember, you have to write the formula, the correct formula, in order to get credit for it. There's two square roots here, so this presents the opportunity for making some mistakes. So one way that I would suggest that you might go about solving this is key into your calculator the numbers for the first factor, the 2ds over h. Take the square root of that number, hit the square root key. Then most computers have a memory. Just hit the memory button, add it to memory. Then do the calculation for the p divided by p minus u. And once you've taken the square root of that, then you just multiply, hit the multiply button on the calculator, and then hit the memory recall, and that will bring back the previous calculation that you've done, and then hit the equal key, and you have your answer. So in this case here, the economic production quantity is 1,013. Now I'm using three decimal points because the numbers just don't turn out even like they did in the first question, the first EOQ problem. But you should not worry about decimal points on the assessment quiz, okay? Do not worry about decimal points. Second question is, what is the maximum inventory achieved? So if we look at our formula sheet, we see that we have a calculation here for that. So it's the economic production quantity divided by P, and multiply that times the difference between the production and the usage rate. So that turns out to be 759.9. The next question is, what is the average inventory? Now, notice that the average inventory for the economic production quantity is not the same as the average inventory for the economic order quantity. So go back and look at the other problem. It was just EOQ divided by 2. In this case, it's similar, but it's not the same. It is Imax divided by 2, not EPQ divided by 2. So we've already got Imax, so half of that is 379. The next question is, what is the length of a production run? So every time that we set up and do a production run, how long will it take us to produce this economic production quantity of 1,013? So if you look at your formula sheets, you'll notice that there is a formula for runtime. So runtime is the economic production quantity divided by the production rate. So that calculates to be a little over 5 days to do a production run. And then finally, the last question is, what is the total annual cost of producing and storing for this coupling? Okay, so our formula for it is that formula, the fourth from the top. So Imax divided by 2, that's average inventory, we already know that, times the holding cost. Now, the annual demand divided by EPQ, if you look at your formula sheet, what that is, that calculates the number of production runs that we are going to have in a year. So it's essentially the same formula for EOQ for the number of orders that you have per year. But in this case, we're not ordering, we are producing. So how many production runs will we have per year? And then what is that setup cost that we incur every time that we do a production run, which is 70. So these two numbers should be exactly the same or very, very close to each other. So we can see these calculations here that we're just off by 1 penny between the total annual holding cost and the total annual setup cost. And so the answer to this question would be 1519. So I'm going to go back and end the sharing here. So this is what I wanted to cover today. Okay, I got a question from Ryan, so I'm going to open it up for questions here. So Ryan says, just to clarify, we will have the formulas only, correct? That's correct. No variable definitions or no formula names, okay? That is correct. You're just going to have the formulas only. That is why I sent those to you, and that is why I'm taking the time to go through this now. Okay, David is typing. How much time will we have to complete the quiz? Okay, David, the allowed time is 1 hour. 1 hour, and you should be able to do it comfortably with it. Okay, will it have the same format as the exams? The answer is absolutely not. Okay, so go back and read the information that I've given you so far. So this assessment quiz is first of all, it's a paper quiz. It's not an online quiz. The second is it is pure math. So it is not multiple choice and true false. It's going to be very similar to the two problems that I have just worked for you. Okay. Vicki, any questions from you? Okay, I think I might have missed it when you were going through the example, but how do you find lead time? Lead time is going to be stated, okay? Lead time is used in the reorder point calculation, but what may not be stated is the value for the little d in that formula, okay? So the little d stands for the demand during the lead time. So the unofficial formula for little d is capital D divided by the number of work days, but lead time will be stated. Are we required to label our answers? No, you're not required to label your answers. If you want to do it, that's fine, okay, but that's not part of the grading criteria. So let me go over the grading criteria. So there are 2 problems. There are 5 parts to each of the 2 problems. So there's 10 different calculations that you're going to have to do. And for each of those 10, there are 3 potential points that you can earn. for a total of 30 points for the entire quiz. So if you write the correct formula, then you will get 1 point. If you insert the correct variable values into the formula, that is worth a 2nd point. And then if you calculate the correct answer, that is worth a 3rd point. But once again, let me caution everyone that when you calculate the economic order quantity and when you calculate the economic production quantity, since those calculations are used in the following questions, if you make a mistake in the EOQ and EPQ calculation, it's going to compound your errors with the further ones. So you want to make double and triple sure that you have those calculations correct. Okay, does that take care of everybody's questions? If not, okay, he's right. Okay. Round all over. Okay, Ryan, you will not need to worry. If you want to use 2 decimal points, you can. Okay. But I'm going to be grading your assessment quizzes, not your TA, okay? And that's the least of your worries. Okay, so final round for questions. David, you got any? Vicki, you got any more questions? Okay, so that's it, guys. So you have a homework due, okay? You have a homework due today. If you haven't done that, make sure you do that. And make sure that you review that formula sheet. And I'll be putting this recording out for anyone who was not able to attend today's live session to be able to see it. So good luck on the assessment quiz, and I'll let everybody know maybe probably toward about this time next week how everything worked out. So have a good weekend.